So in spherical coordinates, the connection between rectangular and spherical is rho sine phi cosine theta. This is the same theta as in cylindrical. It's that theta that we were just showing. Phi is the angle measured from what?
Z.
The positive z. Good. And then y is equivalent to rho sine phi sine theta, and z is equivalent to rho cosine phi. And that's how you represent your vector equation. You say this is what I'm going to follow to trace x. This is what I'm going to follow to trace y, and this is what I'm going to follow to trace z, and I've just written a common way to express it. It's a function, you're plugging in rho. Well, you know what, the rho is going to be fixed for any particular sphere. So you could replace, for this one, you could replace rho with A, okay? Okay, for the sphere that we're talking about up there, the rho is going to stay A. It's going to be equal to the radius. Because remember, the sphere is the shell of the sphere. It's not points within it. If you want to talk about points within it, then, you know, you have to, so if we're just talking about a sphere, it's the shell that's the sphere. So the radius, or rho, is going to stay A. So you can replace, if you're really trying to represent that sphere, then you want to replace rho with A. And then my variables that change are phi and theta. So this would be a common way that you would see it written. If you see these brackets, I mean, it's kind of like you're just writing coordinates of a point, but by putting these little brackets, it just means you're really expressing it as a vector, meaning you're imagining starting at the origin and moving out to, you know, this point. Another way that you might see it represented, and it seriously, it doesn't, there's no difference between the two. It's just like two different ways to write down the same idea. This is the coefficient that is giving me my x-coordinate. We could represent a vector by expressing this coefficient times, this is not the square root of -1. I wish that, you know, they don't have that overlap.
So if I'm writing a vector, don't most people like a little hat caret thing over?
Yeah, you can. I see it typed in books enough where they don't do it, and just from the context, you're supposed to know it's not the square root of -1. But yeah, you can put the little thing on top to make sure you're. But what I is, it's a unit vector in the x direction. So it's the vector 1, 0, 0. So this is giving me the coefficient of x. If I multiply it by the unit vector 1, 0, 0, then x becomes what this is. Y and z are still 0. And then you would do the same thing for the y direction. J is the unit vector in the y direction, the positive y direction. So if you multiply this coefficient by 0, 1, 0, then x stays 0, z stays 0, but y becomes that coefficient. And then you could do the same thing for the z. K is used to represent the unit vector in the z direction. So if I multiply this with a cosine phi, x stays 0, y stays 0, z becomes what that coefficient is. So these two things are just two different ways to talk about the same thing. They're just two different notations. And
I don't care which one you tend to like better.